Hey, Tans. Thanks for coming along. It's nice to see everyone on the chat. Already halfway through the register, which is great. Missing Zihan, Ethan, Boyang, Ryan, Oleg, and Mary. Hi again, different account. That's absolutely fine. There's Ethan. Yay! Ethan in the house. Just missing a couple of people. Zihan. There's Oleg. Amazing. Doing very well. Z, Boyang, Ryan, and Mary still to come. Is my sound okay? Boyang, that sounds fine. Mary's in the house. Hi, Mary. Just Z, Boyang, and Ryan now to go. Nearly done. That'll be good. And then, guys, we can crack on with reacting mass homework. We're going to go through the homework, see how you guys got on. And then we're going to look at water crystallization, which is question 10. It was a hard one. I didn't expect you guys to be able to do it. I think I said on the classroom, don't worry if you can't. Yeah, you didn't even need to try question 10. The hint is it's all about counting particles. That is the key to this. I'll mark Z as missing, Boyang as missing, and Ryan as missing. Oh, Jess is in. Hi, Miss Ryder. It's nice to see you. I'll mark those guys as missing for now, and then I'll update them later on when they arrive. I think that's very reasonable. Right. Okay, guys, let's crack on. So the first thing we need to do is go through your homework. I hope everyone managed to get it done. Can I have a can everyone just give me a yes that you managed to get the homework done? On the chat, say yes if you managed to get it done. We can then update our scores and our tracking sheet. Should be good. Right. Share screen. All you guys are writing yes. Yep. Oh, look at that. 5 yeses straight off the bat, which is amazing. Yep. Awesome. Amazing. Guys, really happy. Thank you so much. No, I'm not smart enough. Don't believe you, Kate. Don't be silly. Right. Okay, are we ready? Now, the key thing is rounding errors. Yeah, key thing is rounding errors. So we've got, just to make sure that we are taking the time not to get any rounding errors for our final answer. So it's keeping the number on your calculator. That's one of the tricks. So it says, let's extract the data. Calculate the mass of aluminium. So this is what we want. I want him that can be formed from that much aluminium oxide. Okay, so we have got, I'm going to do all of this in this small space just underneath it because that's how I tend to do it. I tend to like to lay it out. 1,020 grams. Perfect. So I've got this guy. I'm going to shrink my pen so I've got a bit more space. So I've got 1,020 grams of that guy. Chemists don't work in grams. Step 1, get to moles. Number of moles is grams over rams. The question is, what's the rams for aluminium oxide? Aluminium on the periodic table has a mass of 27. There are 2 of them. Yeah, I'm then going to add that to oxygen, which has a mass of 16 on the periodic table, times by 3. I have no idea. 102, got that number in my head. 27 times 2 plus 16 times 3, 102. There we go. So number of moles equals 1,020 over 102. They've done that deliberately. Yeah. 1,020 divided by 102 on my calculator gives me 10 moles. Right. Step number 2. Step 2 is mole ratio. Use the ratio, which comes from the equation, and the ratio is 2 to 4. Let's just underline those. Yeah, 2 to 4. That's my ratio. Now, I'm going to do something a little high. Sorry, I came late. No problem, Boyang. I'll update that on the register. It's good to see you. I don't think Ryan's here yet. Is Ryan here yet? No Ryan and no Zihan. Okay, so the ratio, I'm actually going to do the oxygen as well, just for fun. But in reality, that is actually all you need to do. Yeah, I'm going to go to the oxygen as well, because it just means that the mass will add up. But remember, you don't need to do that step. They've not asked you to do it. This is very typical GCSE. Oh, Zihan. Hello. Z-Han rocking up. There we go. Just Ryan missing now. So just the answer for this particular question, a 2 to 4 is the same as a 1 to 2. There's no difference. Because if I want to get a 2 to a 4, this is going to be a times by 2. So that's going to become 20 moles of aluminium. Right, now the problem is step number 3, get out of moles. We need to reorganize that equation. Yeah, so number of moles equals grams over rams. I want grams times, we're going to make grams the subject of the formula by timesing both sides by rams, and it will vanish from that side. So I need to multiply this by the weight of aluminium. And aluminium, we've already found on the table, is 27. You don't need the 4. The 4 has already been used in the ratio step. Yep, so times that by 2, times by 2 gets me to 20 moles, times by 27, and I have got a mass of 540 grams. Guys, there's your answer. Give me a quick on the classroom, on the chat, please. Give me a yes if you got it right, and a no if you didn't. Now, just for fun, yeah, you know, I always like doing the extra. If we were going to go from 2 to 3, that would be a divide by 2 times by 3 on the moles. I've got the moles, which is 10. 10 divided by 2 times by 3 gives me 15 moles of oxygen. What does oxygen weigh? Oxygen weighs 16 on the table. Look at that. Yes, 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 yes. That's awesome. Guys, if you can do this, you can do anything. Yeah. So I'm just playing around now, folks. We know that oxygen weighs 16, but it's in a pair. Oxygen weighs 32 as a gas. So times by O2, which is 32, because it's 16 times 2. So 15 times by 32, and I get 480 grams, and mass adds up. That's just me doing it for fun. Yeah, that's all. Don't even need it. 540 is your answer. 1 mark if you got it. Boom. I'm loving it. Just like McDonald's. Next. Okay, next question. Come on, tablets. Take a bit more slower than it doesn't work as fast as I do. Calculate the mass of oxygen. Right, put my question mark over somebody. It wants me to find oxygen this time. Wants this guy. Yeah, that reacts with 10 grams of calcium. Okay, we're in. So I've got 10 grams of calcium. Step number 1, get to moles. S1 is moles. I always write down the equation. Number of moles is grams over rams. Yeah, sorry about my tablets hiccuping a little bit, folks. I should have restarted it before your lesson. Grams over rams. Right, so number of moles is grams, which was 10. How much does calcium weigh? Find it on the periodic table. Calcium has 2 numbers, and the top number is what matters. So it's over 40. So 10 divided by 40 gives me 0.25 moles. That's Christmas moles, by the way. So what's the ratio? It was a 2 to 1. That's the only, this is step 2, is the ratio. Yeah, how do I get from a 2 to 1? Divide by 2. So I'm going to divide that number by 2, and I get 0.125 moles of oxygen gas. How much does oxygen weigh? Oxygen weighs 16, but it's in a pair, so it weighs 32. Reorganize the equation. Number of moles equals grams. I only remember one equation, and I just reorganize that. Bring the rams over. Rams times moles gives me grams. Yeah, so times that by 32, and I get a mass of oxygen of 4 grams. Just for fun, just for fun, that's a 2 to 2. So that has the same number of moles as the calcium did originally. Yeah, times by what does calcium oxide weigh? Well, calcium is 40 plus oxygen, which is 16. So that weighs 56. Times that by 56, 0.25 times 56, and I get 14 grams. Look at that. Mass is conserved. Boom! 4 grams is your answer. Tick it if you got it. I don't know why I'm answering. 4 grams. There you go. 1 mark for that. Give me a shout out on the classroom. Anyone after Amber? Give me a yes if you got it right. I'd like to have Bo Yang, did he get it right? Kate, did he get it right? Chimon, did he get it right? I want those people who didn't contribute before. It's nice to be able to give me a bit of a heads up. Adri, yes, well done. Oleg, yes, well done. Fatima, Chimon, yes, well done. Chimon, good job. Bo Yang, yes. Zihan, yes. Oh, this is awesome. You guys are smashing it. Next. Right. What mass of propane? Had a look at what propane was. That's this guy here. Yeah, so what mass? I'm going to put the question mark there. Burns in 48 grams of oxygen. So I have 48. I'm going to change from red. I don't like red. No. Just no. 48 grams of oxygen. That was 48, wasn't it? Yeah. 48 grams of oxygen. Step one. Yeah. Step one, get to moles. Number of moles. Grams over rams. So number of moles equals 48 divided by, what does oxygen weigh again? We get used to this. 32. We get used to this stuff, folks, because oxygen's in a pair. Oxygen weighs 16 on the table, times by 2. 48 divided by 32 gives me 1.5 moles. Next, what is my ratio? It is a 5 to 1. How do I get from 5 to 1? Divide by 5. So I'm going to take that 1.5 divided by 5, and I get 0.3 moles. Christmas moles. Right, now I need to get out of it. I've used that step 2 done. Step 2, tick. Step 3 is get out of moles, reorganize. Number of moles times by rams. Yeah, I've just reorganized it. Give me grams. How much does propane weigh? Right, the carbon on the periodic table weighs 12, and there's 3 of them. And then hydrogen on the periodic table weighs 1, and there's 8 of them. Total it up. 12 times 3 plus 8, it weighs 44. Multiply 0.3 by 44. So 44 times 0.3, and I get 13.2 grams. My tablet's being problematic. 13.2 grams, and I'm done. If you really want to go the extra mile, check this out. The ratio, 3 to 4. This is the reason it doesn't really take any longer. 0.3 times by 3. I'm just going from here to here because it's 1 to 3. It makes it easier. That's 0.9 moles. And then 1 to 4, 0.3 times by 4. I know, gone Yorkshire. Times 1. Carbon dioxide weighs 44. Times by 44. No, and that water weighs 18. Get used to these after a while. I know all these numbers because I'm a geek. Times by 18, I've got 21.6 grams of water. It's French for water. I'm just gonna stay silent. Kate, if you have got the last 2 wrong, can you do me a favor? Can you now just you can pause the video and can you have a go, please, at the next 2 and then watch the video through? That would be grand. Yeah, 44 times by 0.9, and I get 39.6 grams, and I'm pretty sure mass is conserved. Winner! 48 plus 13.2 gives me 61.2. 39.6 plus 21.6 gives me 61.2. Mass is conserved. The answer, of course, was that one. Gives you the mark. Whoop, whoop. There we go. If you got 13.2, you're a winner. Next. Okay. Yeah, so Kate, have a go at the next one. That would be grand. Pause the video, have a go. Next. Right. I need the masses. Who am I after? What do I want? No. Right, next question. 20 grams of hydrogen. So I'm going to put 20 under here. 20 grams of that guy. And ammonia wants this guy. Wants ammonia. Okay, that's a tricky one. 3 to 2 ratio. Step 1. Step 1, grams over rams. 20 grams over. What does hydrogen weigh? Well, hydrogen on the periodic table is 1, but it's in a pair. It weighs 2. So 20 over 2 gives me 10. That's easy. 10 moles again. Don't even need a calculator for that bad boy. Step 2, ratio. Yeah, this is moles. Get to moles. Yeah, ratio is a 3 to 2. Right, how do I get from 3 to 2? Divide by 3 gets me to 1. Times by 2 gets me to 2. 10 divided by 3 gives me that, times by 2 gives me, going to get rounding errors now, folks. 6.666666, you get the point. 3 sig fig, 6.67, but I'm keeping the number on my calculator. How much does now we need step 3, get out of moles. Number of moles is grams over rams. Reorganize, bring rams over, times by rams. Yeah, how much does ammonia weigh? Nitrogen is 14, and there's 1 of them, times by 1, plus hydrogen, which is 1 times by 3. Yeah, so weight total is 17. Multiply that by 17, the weight of ammonia. So times, I've kept that number on my calculator, times by 17, and I make 113 grams. Tick it if you've got it. Amazing. Next. Smashing through them, folks. Smashing through them. Let's go to the next one. What mass of... my tablet. Come on. Just behave, will you? What mass of sodium hydroxide? Want him? Ugh. Really irritates. Doesn't work as fast as I do. Is neutralized. It's a trap. They've given us kilos. Got to switch to grams. 24.5. Okay. I've been given 24.5 kilograms. There's an extra step. Yeah. Step number 1 is get to moles. Number of moles is grams over rams. I haven't got grams. I've got kilograms. So convert to grams. Times by 1,000. Yeah. Now over the weight of, right. So how much does sulfuric acid weigh? Hydrogen is 1 times by 2 plus sulfur, which is 32. Sulfur on the periodic table is 32, and there's 1 of them, plus brackets oxygen at 16 times by 4. I have no idea what sulfuric acid weighs. 2 plus 32 plus brackets 16 times 4. 98. So it's over 98. 24,500 divided by 98 gives me 250 moles. Right, step number 2, ratio. Yeah, the ratio is a 1 to 2. Double it. 500 moles of sodium hydroxide. Right, now we need to get out of it. That weighed 98. So now we need to get out of it. Reorganize grams over rams. Number of moles times by rams gives me grams. Right, how much does sodium hydroxide weigh? Blimey. Sodium is 23 on the periodic table, and there's 1 of them, times by 1. Brackets plus oxygen at 16 times by 1, plus hydrogen, which is 1. Yeah, so 23 plus 16 plus 1, 40. Yes. So I'm going to multiply that by 40. 500 multiplied by 40 gives me, I'm going to need 20,000 grams. Yeah, 20,000 grams or 20 kilograms. If you've got either of those answers, you may have the mark. Boom. Winner. Next. Moving on. Doing well. You realize I don't even need half the space, but I am writing tiny. Yeah. Next. What mass of carbon dioxide? So they want this guy. This tablet. This CO2. What mass of carbon dioxide when 7.41 grams of copper 2 carbonate is thermally decomposed? 7.41 grams. Okay, zoom in. Zoom. Step number 1 is get to moles. Yeah, step number 1, moles. Number of moles is grams over rams. What does copper carbonate weigh? Yeah, 7.41 over, right, what does copper carbonate weigh? Notice that I do it off to the side, by the way. Yeah, copper is 63.5 on periodic table, times 1, plus carbon, which is 12, get used to him. Yeah, I see him a lot. Plus an oxygen, you see a lot, 16 times 3. No idea what copper carbonate is. I'm going to say 120 something. 63.5 plus 12 plus 16 times 3. 123.5. Did know that number, actually. There we go. 7.41 divided by 123.5 gives me 0.06 moles. Right, what's ratio? Ratio 1 to 1. That's nice. Copy number over. Don't even need to do anything. Times nothing. Yeah. Right, now I need to get out of moles. Rearrange calculation. Number of moles times by rams will give me grams. Yeah, so what does carbon dioxide weigh? Carbon dioxide's carbon's 12 plus 16 times 2 weighs 44. I'm a nerd, I know that. Times by 44, and I get answer 2.64 grams. Grams, and we're done. Winner. Absolute jackpot. Hasn't changed my pen again. Stupid tablet. There we go. Doing well. Okay, give me a heads up, folks. I want you to give me the number out of 6 so far, please. Give me your number on the chat. Do you get between 1 and 6? Lovely to see. It's going to be nice to see loads of 6s. I've got a feeling I'm going to see loads of 6s. Yeah. Next question. Look at that. Yup, Oleg. Yup. Amazing. What mass of carbon monoxide, need this guy. Hello. Need that guy. Reacts with, I'm so sorry. Let's look at this. 6, 6, 6. Absolutely smashing it. So try Welsh accent. Not very good at a Welsh one. Should try and practice more. So we're looking for carbon monoxide. It's going to react with iron 3 oxide. Yeah. God, Welsh is really hard. I find Welsh really tough. Can try and do a Scouse accent. It's going to react with carbon monoxide, lads. Reacts with 2 point. I'm sorry. I'll stop, guys. I'm so sorry. Where's my mass of iron? Look at this. 6, 6, 6, 6, 6, 6, 6, 6. Loving the 6s. All the 6s. Sorry, tablet's really struggling. 2.08 kilograms. Okay. 2.08 kgs of that guy. Step number 1, get to moles. Grams over rams. Right, so we need to convert from kilograms to grams. So first step, that's going to become 2,080 grams. Divided by, what does iron 3 oxide weigh? 160, I think. Iron is 56 on the periodic table, times by 2, because there's 2 of them in it, plus oxygen at 16, times by 3. So 56 times 2, plus 16 times 3, plus brackets, 16, plus 16 times 3. 160. Weighs 160 there for iron 3 oxide. Yeah, there we go. Total 160. It's nice to show the calculation. Okay, so 280. 2,080 divided by 160 gives me 13 moles. Next step, use the ratio. Yeah, ratio. Ratio is a 1 to 3 times by 3. Yeah, times that number by 3. Get 39. 39 moles of carbon monoxide. Right. Now I need to get out. Reorganize. Number of moles times by rams gives me grams. How much does carbon monoxide weigh? No idea. Carbon is 12 plus oxygen is 16. Weighs 28. Is that right? Yeah, weighs 28. Times by, I'm going to do my calculator anyway. 12 plus 16 is now really awful. Times by 28. So 39 times by answer gives me 1,092 grams, or, if you prefer, 1.09 kgs. Done! Winner! Either one of those numbers is a win. There we go. Next. Smashing through it. Doing well. Come on, tablet. Come on. There we go. 20 grams. 20 grams of iron. So I've got 20. Didn't do that. 20 grams of iron to form. What mass of chlorine will react with it? Boom. Okay. So step 1, get to moles. Yeah. So grams over rams. Iron weighs 56. We know that. Yeah, from the previous question. So 20 divided by 56 gives me 0.357. But keeping the number on my calculator. Ratio. Step 2. Ratio. You've got to say it with an R, remember. You've got to roll it. Ratio is a 2 to 3. I need to go from there to there. Divide by 2 times by 3. So I'm going to keep that number as on my calculator. Yeah, 0.357142857 divided by 2 times by 3 gives me moles of 0.536. But keep the number on my calculator. Number of moles times by rams gives me grams. How much does chlorine weigh? Chlorine on the periodic table is 35.5, but it's in a pair, 71. I'm going to multiply this number here by 71, and I will get, number is on my calculator, times by 71, and I get 38.0 grams. Boom! It's a win. Tick it if you got it. Next. Okay. Doing really well, folks. Doing really well. We've got 2 more questions to go. Smashing our way through it. This is great. Next, hydrazine as rocket fuel. Love hydrazine. Never actually met hydrazine. It can be made by reacting ammonia with hydrogen peroxide. What mass of ammonia, right, question mark, question. What mass of ammonia is needed to make 148 grams of hydrazine? Zoom in. Boom. Right. Step number 1. Get to moles. Yeah. Number of moles is grams over grams. Right. So number of moles equals 148 divided by, I have no idea what hydrazine weighs. Nitrogen is 14, and there's 2 of them in hydrazine. Plus brackets, hydrogen is 1 times by 4. 14 plus 14 plus 4. 32 over 32. 148 divided by 32 gives me 4.1. No. 4.625 moles. What is my ratio? My ratio is this is step 2. Ratio is a 1 to 2. So double it. Double the number on my calculator. 9.25 moles of ammonia are needed. How much does ammonia weigh? Already done that earlier today. Ammonia weighs 17. Multiply that by 17 times 17 gives me 157.3 grams. And in fact, a 3 sig fig, I'm done. There we go. 157 grams, guys. Tick it if you got it. Whoop, whoop. There we go. It doesn't say 3 sig fig, so if you've given it to more decimal places, that is absolutely fine. Right, guys, this is today's lesson. Right. So I'm actually going to ignore this question, folks, because this question is today's lesson. So, guys, can you please go to your homework tracking sheet, please? Let's go to the homework tracking sheet. Yeah, which is there. There we go. I know that's some, yup, and the last one. We're going to ignore that Z, so it's out of 9, I think. Trying to find it. Lol, Boyang, that's amazing. Let's add in some information. So this one here was reacting matters. Reacting mass. Homework. And it's out of, what was it out of again? I don't even remember. Can't even remember. 9. It's out of 9. Because I'm going to ignore the last question because it's my lesson today. So it's out of 9, folks. Out of 9. There we go. So it's out of 9. There we go. I'm actually I want to shrink some of these columns. Not that it matters. There we go. I'll do that later. So it's out of 9. You can fill in your data, guys. That would be wonderful. But what if we managed to do it? Oh, Ethan, that's absolutely fine. You're absolutely right. You probably did manage to do it. And I really love to think that you did. That's great. You can even add that one on. You can add 10 if you really want to when we go through the lesson. Because I'm going to come back to that lesson at the end, you say. That question's going to be at the end of the lesson. Look at that. 9s and 8s. Outstanding. Guys, if you can do that, you can do anything they throw at you at GCSE. Anything. Right. Today's lesson. Okay. Title of today's lesson. I'm going to zoom in more, I think. Water of crystallization. Okay. Right. So the first thing I need to do is I need to explain what this is. Yeah, explain what this is. So you guys have done bonding before you started calculations. So you guys know what an ionic compound is, and you know things like salt. Yeah. So first sentence. When solids form in solution. Now that seems like an odd sentence in itself. This is when crystals form. Whenever you make salt, that sentence itself seems a bit odd, isn't it? This is any precipitates. You don't really need to worry about this bit of understanding, guys, if you don't know. But if you take salt water, seawater, and you evaporate it. Oh, I've just lost my board for some reason. Uh-oh. My board has vanished. Oh no. What have you just done? That was weird. There we go. So if you take seawater and you evaporate the water, you will form solid crystals. The salt will appear as crystals. Every one of you should have done this in class by now. Yeah? Well, it turns out that some salts, when solids form in solution, sometimes water brackets H2O gets trapped inside the crystal. Now, the way that we represent this is by doing something like this. Cu, this is the most common one that Edexcel love to ask, is with a dot. Yeah, this is a dot. Dot 5 H2Os. You need to know this one. Is there learning objectives? I'm not going to bother with the learning objectives today, Ethan. I just want to get my lesson done. We can do the learning objectives at the end if we've got time. What are we doing now? Lol. Just watch the video at the start of this. We're talking about water. We're doing question 10, Kate. I'm going to talk you through question 10. Now, this here is called a hydrated, this is hydrated copper sulfate. Copper 2 if you really want the Roman numeral, because it is a transition metal. Yeah, this is hydrated copper sulfate, and you've got to know this guy because it's blue. It's very pretty. Let me show you. It's just always nice to do this. Yeah, hydrated copper sulfate. Don't really need the 2 for copper. It's an oddity. Yeah, you should include it, but not that it really matters. So hydrated copper sulfate is blue. It's very pretty. And look at the crystals. Aren't they beautiful? So these crystals you've probably grown in school at some point. If you haven't, I'm happy to grow them with you over lunchtime if you fancy it. They're very pretty. They're quite difficult to make big ones. It's actually quite difficult. But there are like some, it can be done, and they are really beautiful. They look like gemstones. Yeah, sapphires. I prefer sapphire. So Ryan, hi Ryan. So this is hydrated copper sulfate. Yeah, and if it's blue, it actually tells you. So this is a blue crystal. Just going to color this in. Going to go blue. There we go. It's a blue crystal. Yeah, and if you take away the water, if you evaporate this, I'll put evaporate. Evaporate. If we, I don't like pour being like that, evaporate. If we heat this up, brackets, heat. If we heat these crystals up, they change color, which is kind of cool. If you heat them up, it just becomes copper sulfate. And this is called anhydrous copper sulfate. This is actually the test for water. Anhydrous copper 2 for the Roman numeral sulfate. And this is white. Yeah, this is a white crystal. It's kind of cool that. You actually, the crystals literally change color. No water, no color. And you can see it there. There's the difference. So if there is water trapped inside, then it's blue. If there's no water, it's colorless. It's white. Can't call it colorless. You have to say white, actually. It's rather frustrating, that one. So, and this dot here, this dot, that dot right there literally means, I'm actually just going to take that away and do it again, because that dot there literally says, in chemistry speak, yeah, it literally translates to trapped inside. Yeah, trapped. Yeah, or bound to, sometimes referred to. Yeah, trapped or bound to 5 waters. Trapped with 5 waters. Yeah. So you can imagine that the water molecules are just literally stuck inside the crystal. So, okay, now what you'll notice is there's a very unique number here. It's got the number 5. Now, it turns out that different salts trap different amounts of water, and we can actually calculate this. And the way you do it is counting molecules. Yeah? So, let's say, and this is where I now need to give you the method. So, water of crystallization calculations. Yeah. And here it is. I'm going to say calcium sulfate dot X H2O. What this now says is that this is a hydrated salt, but we have an unknown number of H2O trapped inside. So what do we do to figure this out? So they are going to describe to you, the question isn't just going to be calculate X. They're going to give you this whole spiel, this big talk in the question about what they've done. So what they're going to do is I'm going to teach this through a question. Yeah? Teach this through a question. So the question says, I'll put this in a spangly box in a minute. Question number 1. So 10 grams. I've got to be really careful here, folks, because the problem is if I do this, I don't ever want to give you a calculation that doesn't work. Yeah. So I'm just going to quickly check all my numbers just because I don't want to give you a question that doesn't work. That would be a really bad idea. Yeah. So if I quickly do, I'm just quickly looking up a question. There we go. That'll do. Okay. So in fact, they've given us I'm trying to find a good one. I've suddenly realized I quite like one to be oh, I found one. Okay. Question. Oh, I've not found one. That's a rubbish question. Okay, so question. I'm going to start that one again. Apologize for that, folks. I just can't get the numbers wrong. Yeah. First thing they're going to do is give you an equation. Sodium carbonate. Yeah. This is actually the stuff you buy for the shops. This is, it's actually, no, this is not sodium bicarbonate. That's sodium carbonate. Dot X H2O. And they're going to say sodium carbonate, mass of solid is 286 grams. It, full stop. It is heated until all the water has left. All the water has left as steam. The mass, full stop, the mass remaining is 106 grams. And they will give you an equation. Here's the equation. There we go. Right. And they're going to say, calculate X. That's it. These questions are very recognizable. Yeah, they're very recognizable. And the great thing is there's quite a nice pattern in your answer. So you're going to have these for homework. So whenever you see these questions, the answer, the first step is to draw a line down the center. Yeah, and you're going to put the two things that you made on each side. So you have sodium carbonate on one side and water on the other of that line. That's it. Just draw a line and put water and whatever was before the X. It's literally this, folks. You just draw the line there if you wish. Yeah. Okay. What we now need to do is that's step number 1. Yeah, step 1, this is kind of a table method if you wish. Yeah, step 1. Step 2 is get to mass. Find mass. So, okay, hang on a sec. It said that the whole thing Wait, this whole thing here, I'm going to get rid of that line. This whole thing here, sorry about that. This whole thing here weighed 286 grams. We've heated it until all the water has escaped. And the mass left behind is 106. Right. So I can put 106 underneath him. My first question on the class is, what is the mass of water that has been lost? So that's step number 2, get to mass. Step 3. Now, the problem is, now that we've got to mass, we can now count particles. Yeah, we want to count them. Yeah, and how does a chemist count particles? Moles. Number of moles is grams over rams. We now want to convert these to moles so we can count the number of each of these particles that we have. Yeah, so by the way, the answer to the amount of water is 286 minus 106. 286 minus 106 gives me 180. So my mass of water is 180 grams. That was the mass that was lost. Yeah, the mass that was lost. Okay, now I've got to mass, I need to get to moles. Well, in order to get to moles, I need rams. So I've got the grams. All I've got to do now is figure out what the rams is for each one. Sodium is 23 on the periodic table, and there's 2 of them. I'm going to add that to carbon, which is 12 times 1. Add that to oxygen, which is 16 times 3. Total for sodium carbonate, 23 plus 23 plus 12 plus 16 times 3 is 106. Oh, that's funny. So 106 over 106 is 1 mole. I did wonder. There we go. Right, what did water weigh again? Everyone should know this by now. It weighs 18. Why does it weigh 18? It weighs 18 because hydrogen is 1 times by 2 plus oxygen, which is 16 times 1. It weighs 18. And now, the annoying thing is this is actually going to, unfortunately, then we've got moles. We've actually, because of that, this is going to cause me trouble, this question. Thanks very much. That's caused me trouble. There is a step 4. Yeah, step 4. Divide everyone by the smallest. By the smallest. So divided by 1 gives me 10 and 1. X in front of water equals 10. And we're done. That last step, people are going to go, you didn't need the last step. You do if the numbers are awkward. This just happens to be whole numbers. Total fluke. It was the question I stole from the internet. That wasn't great. Right. Is everyone ready for question number 2? I'm going to do 2 examples. Then I'm going to do the one on the homework. And then I'm going to set you your homework and you're good to go. Question number 2. Question 2. I'm going to pick one that's harder this time, folks. I feel like I want to make one up. Right. They're going to give you an equation. I'm going for calcium sulfate. I've done it now. I'm going to make this question up and hopefully not make a mess of it. Yeah. It's going to get heated and it's going to dry out to form calcium sulfate and X water. Okay. So the question is, the mass of this guy, what was the mass at the beginning and what was the mass after heating? I'm going to be so careful with this. Ooh, just give me a sec. Okay. I'm going to give you 37.7 grams of that guy. Yeah? 37. Oh my goodness, I'm going to make a mess of this. Next, I'm going to heat it. And I'm going to have 22.7 grams left over. It's interesting. 22.7. Right. What is the value of X? Step number 1, draw your table. I need the two products on either side. Calcium sulfate anhydrous and water. Step 2, yeah, so just this is step 1 is table, yeah. Step 2 is find the mass of both. Well, one of them is easy. One of them is 22.7 grams. But what's the mass of water? It's the mass that's lost. 37.7 minus 22.7. Which is going to be 37.7 minus 22.7 gives me 15 grams. I had 15 grams of water lost. Right. Step number 3, get to moles. Well, we all know what water weighs now. Grams over rams. Yeah, grams over rams. 15 over 18, that's the ml of water. We get used to this. What's calcium sulfate? Blimey. Calcium weighs 40, plus sulfur at 32, plus oxygen at 16 times by 4. So 40 plus 32 plus 16 times 4 gives me 136. Right. 22.7 divided by 136 gives me 0.167 moles to 3 sig fig. Next, 15 over 18 gives me 0.833. Now you see why you need the divide by the smallest step. Now we've got to moles. We now need to do step 4, divide by the smallest, by smallest. Yeah? And which one's the smallest? The smallest is this guy. So if I divide that by the smallest, that comes to 1. If I divide that by the smallest, divided by 0.167, and I get an answer of 5. So I actually get an answer of 4.99, and of course everyone goes, oh, that's 5. X equals 5. That's it. Right. You see why you needed the last step. Okay, guys. I'm now going to go back to my very beginning of my lesson. Question number 10. Let's see how many of you got it right. So, step number 1. Use my products, create my table. Sodium sulfate, line, water. Right. Step number 2. Get to mass. So the question says 10 grams of the hydrated. 10 grams of that. Decomposed to give me 4 grams of anhydrous. 4 grams of him. Oh, well, that's nice and easy. So I've got 4 grams of him and 6 grams of water. That's nice, isn't it? It's lovely, makes things easier. Step number 2, get to moles. Grams over rams. Water weighs 18. We're used to this now. No idea what sodium sulfate is. 23 plus 23 plus 32 plus 16 times 4. Gives me 142 for sodium sulfate. I think. Let's check that. Yeah. 4 divided by 142. 4 divided by 142 gives me 0.0282. 3 sig fig. 6 divided by 18. 0.333. Divide everyone by the smallest. Yeah? It means that somebody ends up at 1. And that's kind of the point. Yeah? 1 sodium sulfate for every divided by 0.0282. 12. It's 11.8. The answer, therefore, X equals 12. And we're done. That's it. Oh, I made a mistake. I made a mistake. Guys, I didn't read the question. 4.4 grams. Thought it seemed a bit off. 4.4 grams. I'm so sorry. My bad. My bad, my bad, my bad. I've made a mistake. So that is 4.4 grams. And that, therefore, is 5.6 grams My bad. I've made a mess of that. Sorry. Do it again. Be interesting to see if it still gives me the same answer. Probably won't. Yeah. Try again. Sorry, I didn't read the question. RTFQ. Yeah. Read the full question. 4.4 divided by 142 gives me 0.0309. It's actually 10 actually to 3 sig fig. 5.6 divided by 18 gives me 0.311. Divide them all by the smallest. And I can see the answer already. Yeah, 0.311 divided by 0.0310 gives me 10 exactly. The answer is 10. X equals 10. I'm done. Sorry I made a mess of that, folks. I didn't read the question. No. Right, guys, that's it. We're done. Absolutely to the nail as well. Look at that. 5 minutes left to go. Look at that. It's amazing. Yay, we're done. Ethan, did you get it right? Did you get it right, Ethan? X is equal to 10. Amazing. It's all about counting moles, all about counting particles. Everything comes down. Yeah, well done, Ethan. You're a hero. That's really impressive. I'm really, really pleased. Thank you. Right, guys, I'm going to love you and leave you. Go and have a nice rest of your day. I will set the homework on the classroom for water of crystallization questions, and I will see you guys next lesson. Our next lesson, of course, is on our next lesson is on what? Thank you. Thank you. Our next lesson is on Tuesday. So you can have a go. Yeah, can. I will see you Tuesday, guys. I'll set the homework on the classroom now, so it's all there and waiting for you. Guys, have a great rest of your day. See you later.